Hi, welcome to episode 6 of the H4 plugins series, still on GPIO, looking at the other children of the debouncing GPIO. If you remember previous video, we had the tact list, the counting, the circular, we talked about those. Today we're going to look at these, all the ones that depend on timing. Here's the first one. It's the timed GPIO. Really doesn't show much. There's no point in putting a light on because the value that it sends is the number of microseconds it's been held down for. So just bear with me a second. Okay, that's been loaded into the test rig. Now let's see how good I am at timing 1 second. Okay, press 1000, 2000, 3000, 4000. Oh, that's not bad at all, is it? That's 3.999. Yeah, there we go. So that's microseconds, okay? Almost 4 million microseconds. 4 seconds. Let's try that again. Press 1000, 2000, 3000, 4000, 5000, 6000, 7000 and a bit. Oh well, got ahead of myself. That was almost 7 seconds. If we just stab it really briefly, that was 76 milliseconds. And that's, oh look, 54 milliseconds. We're getting down to the limits of how rapidly you can do that. But you get the idea. There's not much more to say about the time switch. It tells you in microseconds how long it was held down for. Moving on then to the repeating GPIO. It's almost identical to the timed GPIO, but you can see I've highlighted there an additional parameter, which is 1000, that's milliseconds, so that means a second. What the repeating GPIO does is, unlike a timed, which only tells you when you let go how long it's been held down for, the repeating tells you every that many microseconds. So if we watch this, so press and hold 2, 3, 4, 5, 6 and a bit. Now you're going to say, oh, but it's not 1, 2, 3, 4 and 5, is it? It's 199999. Yes, they're microseconds. It's almost impossible on a processor like the ESP8266 to get an exact value of microseconds routinely. So you need to adapt your code to give a little bit of wiggle room if you're going to depend precisely on the values that are coming back. But the most important figure there is the final one, the 648, because that was about 6.5 seconds it was held for. You'll see when we move on to the next one that it's probably not that important to have exact values in here. So don't worry too much about it. Just hang on till I get the next one loaded up and you'll see what I mean. Okay, let's look at the multi-stage GPIO. Now this one takes a little bit more explaining, and gradually we're getting closer and closer to real-world apps, so we need to start putting real-world code in. The executive summary of what a multi-stage button does is it does different things depending on how long you hold it for. So what we have to tell it when we create it is the different times that being held for makes a difference. So in the example we've got here, I've got 2 breaks, one at 2000, 2 seconds, one at 5000, 5 seconds. And the gaps in between, right here and here and here, we're going to call stage 0, means that we've pressed it for less than 2 seconds. Stage 1 means we pressed it for somewhere between 2000 and 5000 milliseconds, sorry. And stage 2 means anything over 5000 milliseconds, 5 seconds. So there's our definition, the multi-stage using that breaks stage map. Now, what we're going to look at is the quite interesting event handler function, because the way that the multistage works is this. The longer you hold it, the more negative the value that you get sent. So if you hold it into this period where you've gone into stage 1, you'll get a -1 sent. If you carry on holding it into here, you'll get a -2. If you had 3 stages or more, which you can if you want to, you'd get a -3. When you release the button, you get a positive equivalent of how long it was held down for. So if you held it down all the time till it got into the stage where it became -4, when you release it, you get a +4. So we've only got 3 values here, 0, 1 and 2. So the longest we hold it, we're going to get a -2. Medium press, we're going to get a -1, and a short press, we're going to get a 0 as it is held down. And then when it's released, we're going to get a 0, 1, 2. It sounds a bit more complicated than it is. You'll see when it happens that it actually makes a lot more sense. But when we get the -2, our longest, we flash using the signaler plug-in. We flash the red LED extremely rapidly. When we get the -1, meaning we've got a medium press, we flash it at a medium speed, and when we get a 0, we just actually switch the LED on and off. Say we've got a short press, we don't start flashing it. So if we release it during the stage when it's a medium press, we get that message. We stop the flashing, and then just to show that something different has happened from putting it on with the short press, we wait half a second, and then 2 times we pulse the LED rapidly, blip blip. So we're going to have a whole section on H4 timing functions on another video, but if we wait for it to go down into the long press, we do a similar thing. Once we release the button, we stop the flashing, we wait half a second, and then 5 times we blip the LED. Let's see that working. So here we go, short stab, short stab. No surprises there. Now I'm going to hold it down for longer than 2 seconds. So hold and 2000, and there we go. See what happened? Let's slow that down. We got the entering the second stage message because we held it longer than 2000. So we were into stage 1. So while it was still being held, we got the -1 telling us that we were in the second stage, and that allowed our code to then start the thing flashing independently. This is the beauty of having H4. We then released it immediately, so it came up in the medium section. There we go, look, medium press. We stopped the LED flashing and we blipped it twice. Now, just so that you can see how the process goes, I'll do it again. Just watch for the double blip at the end. So we're going to hold it, starts flashing, we let it go, pause, blip, blip. Okay, now let's hold it for longer than 5 seconds. Let's clear that window so it's easier to see what's happening. And we're going to go press and hold. We're into stage 1. We're now into stage 2. So I can hold it now as long as I want. It's not going to go, it can't go any further. So whatever happens when I let go, it's going to blip 5 times. Stop. 1, 2, 3, 4, 5. There we go. Okay. We now arrive at the multifunction button. You may have been thinking up till now, well, what would I use these things for? And effectively, all of them have been heading towards this as the final destination. especially when we got to the multi-stage, that can look quite complicated. But just remember the kind of high level thing about what it does. It does different things depending on how long you hold it down. Now this multi-stage button, let me just adjust that. This multi-stage button, multifunction button, is something you're going to come across a lot because it's used in almost all of the sketches that use Wi-Fi, and there's a good reason for that. Now, if you can imagine a multi-stage which has got a stage map of 2000 and 5000, so a short press is less than 2, a medium press is 2 to 5, and a long press is over 5, and then built into its event handling loop, like we've just seen, is that on a short press we change the state of the device. Now I'll discuss that more in a second, but on a medium press it issues a reboot event, and on a long press it issues a factory reset event. When it gets the stage messages negative going into stage 1, it starts to flash the built-in LED, and that's why we need to have the signaler involved here, because that allows other plugins to easily manipulate the built-in LED. That starts flashing at a medium pace. When we go into phase 3, where it's going to reboot into a factory reset situation, it starts going super fast to let you know that something bad is going to happen to your device. So that way I can use a single tact button to switch my device on and off, reboot it, or factory reset it, depending on how long I hold it. Now, all of the stuff we've seen so far were just steps along the way. I need to have a timed button. The timed button needs to repeat so that I get notified of changing states so that I can change the flashing rate. And then I have to be able to do something different when it's released at each stage. So this is where it's all been leading. And because of that, we're not looking at the GPIOs anymore. They're all tied up, hidden underneath the hood of the multifunction button. What comes out of the multifunction button is a reboot event, a factory reset event, or what we're calling a state change event. Now, don't worry too much about that at the moment, but if we do some other fancy stuff, which we'll see another time, which links that state change to an LED or a relay, then it will start behaving in the same way as it does for other stuff. And we're going to kind of make that happen artificially here by turning the red LED to whatever the state changes to. Normally that happens all automatically, but just so that we can see this in action, I've done it this way for you. So the first thing we'll do is a quick short press. Get a state change to 1, we turn the LED to 1. Short press again, state changes to 0, we turn the LED to 0. Just pause that there because I think I might have somebody outside. Yeah, my apologies there, visitor with bad timing. Where were we? Oh yes, short press, state change. So when I hold it down for longer than 2 seconds now, what is going to happen is that the built-in LED, the blue one there, so you've got to watch carefully, is going to start flashing at a medium pace, and then when I let go, the situation is going to reboot. So here we go. Press and hold, state change, release, we get the reboot. See how that works? I'm now going to hold it down for longer than 5 seconds and it will do the factory reset. Okay, ready? Press and hold. There's the first stage happening. Now the second stage is happening where it blinks really, really fast. When I release, it does the factory reset. So that's the multifunction button. Do all of the YouTubey things, you know, like the video, subscribe to the channel and click the bell notification icon, because here's the thing that other channels don't tell you. Every time you don't do all of those things, a chip lets out the blue smoke somewhere.